Okay, welcome to lesson 8 of our probability series. We are going to look at relative frequency. Mastermind, you always have to dream, believe, and achieve excellence. Now, let's go quickly to relative probability. With relative probability, we are talking about ways of estimating probability of an event by experimenting or observing how often it happens over a number of trials. So you are going to do a probability over and over and over and over again. And then you would, by experiment, and then you would observe what will happen over the number of trials that you've done. Now, relative frequency has a formula: number of times an event occurs all over the total number of trials. Now, the more the trials you do, the more the accurate estimate. It is used to actually collect data from real-world events like census, or maybe having a statistical population and all that. And then it is very useful in probability to estimate from experimental data rather than theoretical prediction. So you want to experiment and find your answer rather than you make your theoretical prediction. Now, let's look at some example one. Consider the following frequency distribution table for the ages of students in a class. Now, the age from 11 to 19 with their frequencies or the number they occur. For 11, we have 2. From 12, we have 1. From 13, we have 1. From 14, we have the age of 2. 15, we have the frequency of 3. 16, we have 2. Frequency number of 2 people occurring to be 16 years old. 17, we have 5. And it goes on. 18, 3, 19, 1. Now, find the probability that the student selected at random for the table is a 14-year-old, II, less than 14-year-old, III, greater than 14-year-old, and IV, between 13 and 17-year-old. So you find the total number of students. That will be the total outcomes of this particular type of frequency or this particular type of probability. So you have all frequencies added together, giving us 20. And then probability that the student is 14 years old. So from the table, you can see that the number of 14-year-olds are 2. So then using a formula of relative frequency, we have number of outcome for the probability we are working with all over the total number of students. That is 2 over 20. And we have 1 out of 10 for that. Now, less than 10. Probability that the student is less than 10 years old. We have ages less than 10 are 11, 12, and 13. And if their frequencies were 2, 1, 1, which is 4. Let's check that. 11, 12, 13. You can see 11, 12, 13, 2, 1, 1. That's right. Then we have probability less than 14 becomes 4 out of 20, which is 1 out of 5. Now, the probability that the student is greater than 14 years old. The ages greater than 14 are 15 to 19, right? And the frequencies are written as below: 3, 2, 5, 3, 1. Let's check that. 14, 2, 3, 2, 5, 3, 1. Okay. So from 15, sorry, 3, 2, 5, 2, 3, 1. 3, 1. Let's check that again. Okay. 3, 2, 5, 3, 1. That's right. So now that we are done, we can have a relative frequency formula of the number of trials all over the total number of trials or outcomes. 14 out of 20, which will give you 7 out of 10. Now, probability that the student is between 13 and 17 years old. Between 13 and 17 years old. So between numbers that are between 13 and 17 are 14, 15, 16. So you write the frequencies, that will add up to 13. Is that right? That will be 3, 2, 3, 2, 3, 2 with 7. That will give us 7 over 20, right? All right. Let's look at a second question. A die is thrown 200 times. The outcomes are shown as in the table. So we have the outcomes. The outcome of a die is out from 1 to 6, right? And then we trade 200 times. It falls on 1, 25 times. It falls on 2, 30 times. It falls on 3, 45 times. It falls on 4, 28 times. It falls on 5, 40 times. It falls on 6, 32 times. Now find the probability of obtaining 2, at least 5, at most 3. So solutions. Probability of obtaining a 2 is the number of times 2 occurred is 20, but the total rows, that is 200. So 30 over 200, and we have 3 over 20. Probability of obtaining at least 5 means that at least 5 means 6, 5 or 6 is less. At least means that greater than or equal to. Take note, greater than or equal to. At least, anywhere you see at least, means the greater than or equal to the number you have been asked at least, or equal to the greater numbers in front there. All right. So having that, you have 5 occurred 40 times, 6 occurred 32 times, and you add that 40 plus 32, you have 200, and then that gives us 72 over 200. Simplified to give us 9 over 25. Now, probability of obtaining at most 3. The highest you can go is 3, but you can, and at most, when you find at most anywhere, it is lesser than or equal to, which is equal to 1 occurred 25 times, 2 occurred 30 times, and 3 occurred 45 times. And that gives us this. You add all the probabilities all over the total trials, and that gives us 100 over 200.